Good morning, students. So here in the third chapter of our chemistry, that is atoms and molecules, we are on the discussion of our next topic, that is laws of chemical combination. So today we are going to discuss about the laws of chemical combination. Here basically we have two laws regarding this and the Dalton's atomic theory, the Dalton who propounded the theory for atomic structure. Now we have laws of chemical combination. In laws of chemical combination, we have basically two laws, that is, first law is law of conservation of mass, and second is law of constant proportion. So here we have two laws, that is law of conservation of mass and second one is law of constant proportion. Now we will deal with these basic two laws one by one. So we have first is law of conservation of mass. What actually the law of conservation of mass is? This law will be propounded in 1705 by a scientist known as Lavoisier. The Lavoisier is known as the father of chemistry. He said that the reactant and product in any chemical equation will remain conserved. That is, the number of reactant in any chemical reaction will be equal to number of products. It means mass can neither be created nor be destroyed. It means total mass of a substance will remain to going in constant form. So first we have law of constant proportion. First we will discuss our first law, that is law of conservation of mass. In law of conservation of mass, as I have already told you, this law is propounded in 1705 and this law will be given by a scientist named Lavoisier. Lavoisier is actually known as the father of chemistry. What Lavoisier said regarding the law of conservation of mass, it means number of reactants taking part in a chemical reaction will be equal to the mass of the product in that reaction. It means mass of a system will remain conserved. It means it can neither be created nor be destroyed. So, what actually he said, the first point regarding is this is mass of reactants in reaction is going to be equal with mass of products. The reactant mass will be going to equal to that of the mass of the product. Second point, he said that total mass of reaction will remain conserved third point we have the mass can neither be created nor be destroyed. Mass can neither be created nor destroyed. So here are the basic points regarding the law of conservation of mass, that is mass of the reactant will be equal to mass of the product. Second point, we have the total mass of the system will remain conserved, and third, mass can neither be created nor be destroyed. Here are the three basic points regarding the law of conservation of the mass. Now it is be simply understandable the law of conservation of the mass with the help of suitable example. Now I am giving you example regarding the law of conservation of mass. Now we have an example for understanding the law of conservation of the mass. Suppose we have calcium carbonate in a system and we are going to heat this system. What actually the products we will get? We will get calcium oxide plus carbon dioxide. So this will be the formula for calcium carbonate. This will be calcium oxide and this will be carbon dioxide. Now we will calculate the mass of each term or each reactant or product in this equation. Firstly, we will calculate the mass of reactants. We have mass of reactants. Reactant here we have that is present in the left hand side, and the products we have two products that is present in the right hand side of the equation. We have mass of reactant. Firstly, we will consider calcium carbonate. Mass of calcium 40, because atomic number is 20, so mass will be double, that is 40. For carbon, we have mass 12, its atomic number is 6. We have 3 molecules of oxygen over here and mass for one oxygen will be 16. I am again repeating why I have taken this term 3 here, because the calcium carbonate will constitute the 3 molecules of oxygen. Now we will do this calculation. 40 plus 12 plus 48. So the mass of calcium carbonate will be 100 gram here. So it is the mass of reactant I have calculated here. Now we will calculate the mass of the products. Now we will calculate the mass of the products. Here we have in the product side we have get 2 components over here. First is calcium oxide and second is carbon dioxide. So firstly we will consider calcium oxide over here. In case of calcium oxide, the mass of calcium will be 40 because its atomic number is 20. So mass will be 40 and for oxygen it will be 16. So we will get it 56 gram over here. The second product we have is carbon dioxide. The mass for carbon will be 12 and we have 2 molecules of oxygen here and the mass for one element will be 16. So the calculation here is 12 plus 32, that is 44 gram. I am again repeating why I have multiplied the 2 with 16, because here we have 2 molecules of oxygen over here. So we will calculate the mass of the product. It will be 56 plus 44, that will come to be as 100 gram. So from these calculation we can observe that mass of the reactant over here is 100 gram, that is that of calcium carbonate, and the mass we have obtained here will be 100 gram, that will be the mass of the product. It means mass of reactant is equal to mass of product. mass of reactant is equal to mass of product, and this law is known as law of conservation of mass. So I guess the law of conservation of mass has been clear to you from this example. Now dealing with our second law, the second law we have is law of constant proportion. So we will going to discuss about law of constant proportion. Sometime it may be also called as a law of definite proportion. So now we have our second law, that is law of constant proportion. Now we have our second law, that is law of constant proportion. So sometimes law of constant proportion is also known as law of definite proportion. It is also known as law of definite proportion. What actually the law of constant proportion mean here? It means in the law of constant proportion, certain elements combine to form a product. They will combine in a fixed ratio. It means they are having a constant proportion and the individual elements will not going to belong from the product source. It means the ratio must be fixed over here. So here we have law of constant proportion. It states that element combine to form compounds will be in simple whole number ratio. Second law is the individual elements after combining which the compound is formed does not belong to a compound source. Third point we have is elements do not have any link with the source of product formed. It means in the law of definite proportion, we have a combining capacity of an element in a simple whole number ratio. Now again we will understand this with the help of a simple example. So here we have an example for law of constant proportion. Suppose we have H2 plus O2. From H2 plus O2, we are getting in compound 2H2O. So we will balance the equation in the form, we have 4 hydrogen atoms over here and we have 2 oxygen atom here. So 2 into 2, we will get 4 hydrogen atom in the product, and in the oxygen we have 2 molecules. So we have balanced the equation in the form 2H2O. Now what actually happens here is, we know that H2 will have a hydrogen atom will have an atomic number 1. Oxygen we have atomic number 8. It means if they are going to form a product, they will combine in the ratio 1:8. So here 1:8 we are getting here is a simple whole number ratio. It means this example is going to follow the law of definite proportion because the quantities used here are in the definite proportion, that is 1:8, and 1:8 is a simplified whole number figure. So it is all about the law of constant proportion. So in today's lecture we have discussed about two laws, that is law of conservation of mass and law of definite proportion. In our next class, we will going to discuss about Dalton's atomic theory, and this is all over for today. Thank you so much and have a nice day.